Welcome to Codemap. Today we are going to discuss daily lead code challenge k radius subarray average. Now let's discuss the question. You are given a zero index array nums of n integers and an integer k. The k radius average of subarray of nums centered at some index I with the radius k is the average of all the element in nums between the indices I minus k and I plus 1, I plus k inclusive. Means you have to find the average. For example, you are finding average for a ith index, then you have to consider k element before I index and k element after I index, sum it, and you have to find the average of that element. If there are less than k element before or after the index I, then k radius average is minus 1. And suppose for index I you are finding the average and k element and before that index k element is not there, not present, then for that index the k radius average will be minus 1. Now it is saying that build and return an array average of length n where average I is the k radius average for the subarray centered at index I. The average x element in the sum of the x element divided by x using integer division. The integer division truncate toward 0, which means losing the fractional part. It is saying that you have to consider integer while calculating the average. Now let's understand it with the given example discuss. Uh, here we can see that we have given an array and we are given k equal to 3. So for index 0, we can see that no k element is present before this index. So average k radius average for this index is minus 1. Now coming to index 1, here also we can see that there is no k element present before this index. So k average for this element is also minus 1. Now coming to the index 3, which is 9. So we can see that there is k element before this index, and so we will add a k element before this index, k element after this index, and the element itself, and whatever the sum we will get, we will divide it with the length, which is 7, and whatever we will get the average is our answer. So we can see that sum is 37 and length is 7. Dividing we get 5. So the k radius average for that index is 5. Now in the same way it is calculated for this index also and this index also. Again for this index we can see that there is no k element present after it. So for this index also k radius average is minus 1. Now let's discuss the logic how we can do this. So we can use sliding window approach to solve this problem. We can use window of size 2 into k plus 1, 2 into k plus 1, and find the sum of the window and divide it by the size of the window, we will get the average of that window. So let's uh, let's dry run on this example discuss. So for result, what I will do, I will take a resultant vector res and I will initialize it with minus 1. The size of the resultant vector will be the size of the nums, and all the elements in that resultant vector will be minus 1. Now, mm, and I will take one more variable idx. This variable idx I will initialize it with k, and this variable idx I am taking to I am taking for my resultant vector from where I will start filling my result. I will start filling my resultant vector with index k. Why index k? Because any element before that index will be minus 1, because any index before that will not have k elements before that. So all the element before k will be minus 1. So I will start filling my resultant vector with index k. Now what I will do, I will traverse the given array, traverse this given array, and and I will sum all and I will sum the elements. And when I will see that we have reached our window size, which is 2 into 2 into k plus 1. So in this case, 2 into k plus 1 will be here. So now we can see that we have reached our window size. So what I will do, we will have the sum of the windows, because we will have the sum of the window because we are adding the element from beginning. Suppose we have taken the variable sum for adding to store the sum of the elements of the windows. So we will have some of the element in our variable sum, and we know that the length of the window is 2 into k plus 1. So dividing sum by length, we will get the average. And what we will do, we will store that average at the IDX which I have discussed before. I will place this average at IDX position in our resultant array, and I will increase our IDX. We will do IDX plus plus, and after that we will move our window. So when I will move step ahead, I will add the next element and remove the first element, just like what we do in a sliding window approach. We will remove the first element and add the next element, and again we will get a new sum, and again uh, we will we will have our sum, and we will divide it with the length 2 into k plus 1, and I will place it in the resultant array at IDX and increase the index. Now let's uh, discuss with the code. Here we can see that we have taken a variable n, which is the size of the array. And what I have done, if k is 0, then I have returned the nums itself, because if the k will be 0, our result will be the array itself. Now what I have done, I have taken a resultant variable and initialized all the element with -1, and I have taken a sum of long type with 0, and I have taken an index and initialize it with k, and this index is from where we will start filling our resultant vector. Now I have taken a variable j to implement the sliding window approach, and I have initialized it with 0, and I have taken a length, means length of the window, which is 2 into k plus 1. Now I am running a loop. In this loop, what I am doing, I am adding the element into the sum variable, and if we have reached our window size, means if I is greater than len minus 1, means we have reached our window size. Why len minus 1? Because index, we are starting our index with 0. So if I is greater than equal to len minus 1, means we have reached our window size. And so what I will do, I will place the average at my index position in my resultant vector. And what I will do, I will remove the first element from our sum, which is uh, j, which is 0. And after the completion of this loop, our result will be in the resultant vector, and we will return that result. Now let's run the code. Now we can see that our code has successfully passed all the test cases. Thank you for watching.